afternoon, everybody, and wonderful to see so many of you here at the public forum of the 28th Hydrogen and Fuel Cells Europe exhibition here at the Hannovermesse 2022. I would like to invite all of you to take a seat. We still have some seats left here. The sound only gets better the closer you get to the podium, and the drinks are free as well. So there are some good reasons to take a seat here. And another good reason is the topic I will be discussing, which is hydrogen storage systems for transport and stationary use. I'll be talking about these systems with MAHYTEC, which is a hand-sold company, and I would like to welcome on stage the sales manager, Mathilde Bangoura. Welcome, Mathilde, and I also have to say congratulations, because it's a special day. This is the 10th year that you are here on the fair.
Yeah, I've been there for the first time in 2012, and I can say that it has been growing quite a lot for over the last 10 years, so it's good to see that.
10 years, that's a special anniversary, so congrats on that. All right, so you guys have been here for 10 years, so I think most people have heard of you, but MAHYTEC, what is it you guys do?
So MAHYTEC, we are a company, a French company based on the east of France, and it was founded in 2007 by 4 professors of the university, of a local university, and we are specialized in the design and the manufacturing of hydrogen storage system. I think we are like the only company in Europe which is working on different technologies. So we work on compressed storage that you can see on several exhibitors on this fair, but we also work on metal hydride storage systems, and I think it's quite unique. We are, I think, the only company working on both technology at the same time. And since last year, MAHYTEC has joined a global group called ENSOLD. The head office are in Germany, but it's a group which is specialized in critical electronic systems in the defense area, but they also have a growing business line in energy and also in hydrogen.
All right, and I think we'll get back to the hand-sold story in a bit. For now, I would like to focus on those 2 technologies you mentioned. So compressed hydrogen and metal hydride. Now, compressed hydrogen makes sense to me, right? Like we take the hydrogen, we compress it, relatively easy. So we will be talking about that in a bit. But first, I would like to know metal hydride. How does this work?
So metal hydride, that's a different technology of storage. So the hydrogen is absorbed into a material called a hydride. So it's also called solid storage. And how to make this material? So you take different metals, you melt them together, you get an ingot. And this ingot, you crush it, you get a powder, and you fill this powder into a metallic structure. And that's kind of like a love story. So the metal hydride is gonna, you're gonna take the hydrogen and the metal hydride, put them together. They're gonna start to like each other and get back together, and then the hydrogen and the metal hydride are gonna stay together. And that's a way of storage. And yeah, so it's a reversible way, so you can absorb and desorb the hydrogen. And that's a technology which is quite interesting for several reasons. Well, it's the capacity of this metal hydride is very important, and so you can store a lot of hydrogen in a small volume. So that's really something. And what I can say also is that we, in MAHYTEC, we manufacture our own metal hydride. So there are many different types of metal hydrides. And we work on our own metal hydride, and the thing is we try to focus on metal hydride that do not contain rare earths, and also metal hydride that works with at low pressure and room temperature.
Okay, so no rare earth elements, that's definitely important. And then also you mentioned it has quite a high capacity. If I compare this to compressed hydrogen, for instance, in the same volume, what do I compare this to?
So, well, I can invite you to come over our booth and see the type of tanks that we have.
That's number B67, by the way, for everybody. Yeah.
Please note it. In our booth, we have a tank. The inner volume is a 5-liter tanks, and we can store about 200 grams of hydrogen into this volume. So that's pretty much the same capacity you would have in a 700 bar tank. So that's quite interesting. The good thing also about this metal hydride is that, as I say, it works at low pressure. So it does not require like a heavy infrastructure for compression. You refill it at like 15 bar, so it's quite easy to handle. And that's another advantage. And yeah, the safety aspect is also nice.
So in the same volume as a big 700 bar tank, we can roughly store the same amount of hydrogen in there. But then we don't need the refueling infrastructure. We can refuel it at 15 bar.
Yeah.
It's safer because there's no high pressure.
No high pressure. Yeah.
So what are the disadvantages then? Why is this not used in, say, mobility applications?
Well, it has a lot of advantage, but it has one disadvantage: is the weight. It's a quite heavy technology systems. Because, as I said, you made it from metal, so the metal powder is quite heavy, and so at the end, the system is heavy. So it's interesting for stationary application or for like small quantity of hydrogen that you need to store. And yeah, if you want to get something like transportable, something you can bring by yourself, then that's something that can be quite interesting.
Yeah, I can imagine. And we talked about some applications before, some examples. And you mentioned this this train trolley for coffee. Please tell the audience, what is this project?
Well, it's actually something we got from the Hannovermesse like 8 years ago. And we were working with a railway company in Switzerland. And they wanted to bring more, to offer to their customer more beverage in the train while they sit. And so they decided to have like a mobile trolley that would go around the train. But the thing is, so one of their objective was to make cappuccino. And I often like to think that our tanks were the way to make it cappuccino. So it's like not the kind of application we think about, but and so they wanted to make cappuccino, like real cappuccino, but that needed more energy than what just the battery could take. So they needed a way to increase the autonomy of the battery, and so they turned into hydrogen. But the thing is, they had like, the trolley was already designed, and the shape for the battery was already designed, and they had to find a tank that could fit into that space, and it was like a square shape. And so we designed the tank, and during that time, so we put it into the trolley, and then they were able to increase the autonomy of this trolley and offer the beverage to all the customers during all the train and during for longer trips.
Yeah, and I think you mentioned the lack of high pressure earlier. I think that's an important advantage for an application such as this one, in a train.
Yeah.
And the other one you just highlighted is also quite important. I think the fact that you can make this storage in any shape, because that is not the case for compressed hydrogen.
Yeah, in compressed we really have to stick with the cylindrical phase. But for metal hydride, I bring one on stage. So that's a small metal hydride. As you can see, it's not a cylindrical phase shape. So you can really play on the shape that you want. And for example, this tank was designed for the army, for like the soldier of the future. And the thing is, you can put it on your body, take the heat from the body, and with the fuel cell, like release the hydrogen. A soldier, like he wears about 20 to 25 kilo of battery, so that's quite heavy. And the thing with hydrogen and with those type of things is to try to reduce the weight that a soldier have to wear. And yeah, that's a solution that is considered putting like a metal hydride tanks, using the heat of the body, put it into a fuel cell, and get the energy back. So,
and that heat that is required to extract the hydrogen then from this hydride again?
Yeah, for the metal hydride, you also have to handle the heat. So we work with metal hydride that do not require a lot of heat, like room temperature. So the heat of the body is enough. The heat of the fuel cell is enough. We need about like 40 degrees. So that's pretty much what we need. But yeah.
Yeah, once again, this is obviously an application in which a high-pressure vessel might not have been a good solution for the army, as you can imagine.
Yeah.
And the refueling infrastructure as well, I can imagine. Because at how many bars did you refuel this?
So this one is refilled at, I think, 10 bar max. And at the end, when it's stored inside, it's only like 1 bar. So yeah, you have really no pressure. So that's something that the military, they are interested in as well.
All right, so that was the metal hydride. And then there was also the other technology that you were working on, and that was compressed hydrogen. So tell me, what's special about your tanks?
So there are, as we discussed, different type of compressed tanks. You go from what we call type 1, so the steel tanks, all made of steel. And what we do is what we call type 4. So it's a polymer liner, a plastic liner, that we reinforced with composite materials. So either glass fiber or carbon fiber, depending on the pressure we want to reach.
Okay, and the pressure you want to reach, you have multiple product lines within the compressed hydrogen vessels, I believe. So what are the models you offer?
So we have two main range of pressure. One is what we call low pressure. So it's a 60 bar tanks, and it's designed to be used as a buffer tank in the output of an electrolyzer. So basically, like all the electrolyzer, they have a maximum output pressure of 30, 50 bar, and this tank, it can be put at the output pressure as a buffer tank. And it's a type 4 tank, so in that case, for the buffer tank, it's meant for stationary application. But we see that in power-to-power, sometimes these tanks, they also need to be light. Like we had the case where the tank had to be transported by an helicopter. And that's not always the case where you want to use like steel tank, which are quite more heavy.
All right, and the other one was the 500 bars, I think?
Yeah, so we have one on our booth as well. So the 500 bar, it's a tank that has a double usage. It is approved for stationary application, but also for transport application, so moving the hydrogen from one place to another. And yeah, it's a tank, so also made of a polymer liner, but this time with carbon fiber, since we are handling more higher pressure.
Okay, and if we then look from the customer's perspective, they can buy this tank. Is that all they need? Do they need systems surrounding it? Is that something you guys also do, or do they need to go to other system integrators to be able to use this tank?
So they can buy the tank by themselves. I mean the tank naked, but they can also have some more integrated system. But I would like just to come back on why the 500 bar pressure, because that's not something that we can see often. We chose the 500 bar pressure because we consider it's the best ratio between the energy you need for the compression and the mass of hydrogen that you can transport. So, for example, in a complete system, so I'll get back to the complete system after, but we can say that on a truck, we can transport 1 ton of hydrogen. So that's really something, if we want to consider like the global thing, the footprint, the carbon footprint, I think 500 bar is really something that makes sense. And it also allows to have like hydrogen ready to be used for the mobility at 350 bar. So that's the reason why we focus on this type of pressure and not a lower pressure. And but yeah, so you have the tank by yourself that you can buy and integrate it in any system that you want. But we are also in cooperation with the group, with Hensel Group and Hensel companies, working on like more complete and integrated system where you do not only have the tank, but you have the tank with the valve, with like all the pipings, all the safety instrument, the safety device, or the instrumentation device that you might need, and to have like kind of a plug-and-play hydrogen storage systems.
All right, so that's a collaboration with Hensel then, is that correct? And do you also collaborate with them for other projects, because they are your parent company? Do you collaborate?
Well, yeah, we have several projects going on. We have, we are really focusing on maritime application because we think and we see that it's something that is coming, the need is increasing. So we work on two main topics for the maritime application. So this container filled with 500 bar tanks, we can use it in different way. It can be swapped from the deck of the port up to the deck of the dock, from the deck to the deck of so from the port to the ship. And so that's one thing. And for what we call cold high running, so how you bring electricity to the ship when the engine are turned off. So that's one thing. And the other thing is how to use this hydrogen as a fuel for the boat. So that's the two main topics we are working on. And this container, they are then multi-usage, so, and they are also multimodal in the term of they are approved for road transport, boat transport, train transportation. So, yeah, we've been working on like the main all of these certifications to have the container the most complete possible.
All right, so complete systems. We have almost run out of time, but I think there is time for some audience questions if you do have some. So please raise your hand if you have a question. No audience questions. Okay, well, I do have a last question. And it's about this project we have been talking about before, because your collaboration with Hansold, as you said, you built complete systems. You also told me about this power-to-power system.
Yeah.
For the people who don't know what a power-to-power system is, this is as close to a battery as you can get with hydrogen, I would say. It's a way to store a lot of energy using hydrogen technology. And there was a specific application in Africa, and I really love this story. So I think it would be nice if you can tell the audience as well.
So yeah, I think it's quite a nice project because we see that hydrogen can really be used as a help for population. And so we have this project in West Africa, in Guinea, where so we have a hydrogen box, let's say an energy box that will bring the energy to power a dialysis center. And so with this system, we will be able to, the hospital will be able to treat the people on site, because before they were in a lack of reliable energies. And so with this system, it offers a reliable energy source. So they will be able to treat the people on site, and they will also be able to treat more people than what they were able to treat at the moment. So I think it's really good to see that hydrogen can have like this impact on the life of the population.
Yeah, so also a very local impact for hydrogen, as we learn. That was MAHYTEC, and this was sales manager Mathilde Bangoura, and I would like to get an applause, please.
Thank you.